If you're managing a commercial or industrial facility, you're under pressure from every angle. You've got rising energy costs, tightening carbon regulations, and stakeholders who really want results and not excuses. Many buildings are still bleeding energy and money every single day. Why is this? Well, I could give you many reasons, but fundamentally I think they boil down to a couple. I think basically it's because it may not be sufficiently important enough, or it could also be because building owners and operators actually don't know what to do. So if you're serious about managing energy costs and/or environmental sustainability, energy efficiency isn't just a nice to have, it's actually a necessity. So in this video, I want to give you some strategies that will deliver savings and measurable impact if you are willing to make that investment. Hi, I'm Bruce Rouse from the Sustainability Education Academy, and for most of my career, I've been focused on energy efficiency. So let's look at the cost of energy efficiency. According to the US Department of Energy, the average commercial building wastes 30% of the energy it consumes. That's not a rounding error. That's a direct hit on the bottom line of businesses and their carbon footprint. In industrial facilities, the stakes are just as high. Every wasted kilowatt hour is lost profit, and every unnecessary tonne of CO2 equivalent is a compliance headache just waiting to happen. If you're still relying on outdated systems or ignoring energy efficiency or treating energy as a fixed cost, you're actually leaving money on the table. In today's market, it's not actually just inefficient, it's actually irresponsible. So what does energy efficiency really mean? Well, it's simple. It's just about using less energy to get the same or better services. Whether that service be lighting, comfortable temperatures, delivering potable water, manufacturing a product, doing computations, whatever it is. In short, anything that uses energy, service or product, energy efficiency is simply using less energy to deliver the same service or product. Energy efficiency means smarter technology, better processes, and a culture that values continuous improvement. It's not about sacrificing comfort or productivity. In fact, energy efficiency may improve both comfort and productivity. So if you're a violinist, think of it as replacing the old strings on your violin with new strings and putting rosin on your bow, you're going to get louder, clearer music. If you're a redhead right into cars, think of it as tuning a high-performance engine, or even better yet, replacing the internal combustion engine with a smooth and powerful battery electric drivetrain. You're not just saving fuel, you're getting more power, more reliability, and a longer lifespan out of your assets. And if you're a tennis player, think of it as a new racket or new strings, enabling you to hit the ball, more speed out of it with no more effort. So I want to look at some pillars of energy efficiency in commercial buildings. And a commercial building would be something like an office or a school or a library, some sort of building where the predominant service of the building is for people to do activities that don't involve other than maybe software or what, other things, but they're not actually processing stuff, processing goods. So industrial buildings are a little bit different, or can be quite a bit different, or industrial facilities, and perhaps that's another video. But in commercial buildings, there are several areas where you can make a real impact on energy usage, and today I want to look at 4 of them. The building envelope, HVAC systems, or heating, ventilation, air conditioning systems, lighting and controls. Now, ones that I'm not discussing today include IT equipment and server rooms, hot water, escalators and elevators, and kitchen equipment. But let's focus on these 4, which are, large contributors to energy use in commercial buildings. So the building envelope is actually the foundation of savings, since HVAC, heating, cooling, ventilation, and lighting are typically the 2 largest energy users in buildings. So you want to start with the building envelope. And a key determinant of how much energy a building uses is its interface with the outside world, where it may be hot outside, cold outside, windy outside, humid, dry, cloudy, sunny, rainy. In broad terms, you want to let the outside in when it's beneficial, and you want to keep the outside out when it's not beneficial. So an example of the outside being beneficial is in winter in a cold climate, when it's sunny outside, to get some of that sun's radiation coming into the building and helping warm up the building. An example of the outside being harmful to building energy use would be the opposite, when it's hot and you want to keep the sun's radiation outside the building. You don't want radiation coming into the building. And all the while, you always want to maximize natural light. So it's easy to think that changing the building envelope is too hard and too expensive. And in some respects, you'd actually be right. And this is why climate responsive building design, before the building is built, and incidentally, one of the courses on the Sustainability Education Academy, is so important. On the other hand, there are some things that you can do to existing buildings to make them more efficient and which are cost effective. One of them would be managing air leakage. If your building leaks air, you're paying to heat or cool the outdoors. It's not just wasteful, it's pretty absurd actually. Thermal imaging accompanied with building pressurization testing, often called blower door testing, or taking the thermal images on a windy day with a high temperature difference between inside and outside, can help identify where the leaks are. They may be around windows, doors, roof lines, even through walls. And once you know where the leaks are, those problems are, you can fix them. Other cost-effective improvements to existing buildings include upgrading insulation, which can be of huge benefit when none exists, using external shading, reflective film on windows in hot, sunny climates. In more extreme climates, upgrading windows makes sense too. The payback is real and the comfort improvements are immediate. In cold climates, a tight and well-insulated envelope may cut heating costs by 20% or more. In hot climates, it slashes cooling loads and keeps humidity in check. Now let's look at HVAC systems, heating, ventilation, air conditioning, which is often the biggest opportunity. In most commercial buildings, it's actually the single largest energy user. And if you're not optimizing it, you're wasting money. So start with maintenance. Dirty filters, clogged coils, leaky duct, actuators that don't work anymore or have fallen off the drive. They can increase energy use by 15% or more. But don't stop there. Look at your control strategies. Are you running systems when the building is empty? Are you heating and cooling at the same time in different zones, and are those zones fighting each other? These, unfortunately, are all too common issues. So things you can do to reduce energy use apart from the control settings in HVAC would be to upgrade your control strategy or your heating ventilation system. That's not necessarily a straightforward upgrade, but it can give good savings. Is upgrading to variable speed drives on fans and pumps. You can be installing demand control ventilation so you're not conditioning more outside air than you need to. You can be using smart thermostats and zone controls to match air conditioning to actual occupancy and usage patterns. If your equipment is old, you can consider replacing it. Modern high-efficiency boilers, heat pumps, chillers, and rooftop units can cut energy use by 30 to 50% compared to older legacy systems. Don't forget about heat recovery. Capturing waste heat from exhaust, air, or process loads can provide free energy for heating or preheating. In a hot climate, can also capture free air for cooling. Now, that's lighting. With lighting, depending on the type of lighting you have, you can get some pretty quick wins with big impacts. Lighting may be a low-hanging fruit depending on how recently you've upgraded your lights. If you're still using fluorescence, metal halide, incandescence, or mercury vapor, please hope you're not. You're really behind the curve. LEDs use up to 80% less energy and last a lot longer, maybe 5 times longer. Some other technologies, maybe 10, 20, 25 times longer. Now, the return on investment is over the lifetime of the new lighting is typically well over 300%. So it's a really big, excellent return on investment. But don't just swap bulbs. Install occupancy sensors in areas with variable usage, such as conference rooms, restrooms, storage areas, and even some open plan areas. You know, in my former office, we had occupancy sensors in our open plan areas above every single desk. You can use daylight sensing or harvesting to dim lights automatically when there's enough natural light. That's a fairly complex strategy, but well done, can save quite a bit of energy. In warehouses and industrial spaces, high bay LEDs with motion sensors can cut energy use by half or more and reduce the problem of if you get a short-term power outage with the old legacy lighting, HID lighting like metal halide, it would take ages to get back up to full light. With LEDs, full light is instant. I actually know of car parks who have cut lighting energy use by 80% by installing smart LED lights with inbuilt sensors. Now, let's look at the last one of these 4 issues that I'm addressing today, which is controls and energy management systems, kind of the brains of the operation. Now, if you can't measure it, you can't manage it. And this is where energy management systems and building management systems come in. These platforms can give you real-time visibility into energy usage, equipment performance, and system faults. You can set up alerts for abnormal consumption and use trend data to spot drift and catch problems before they become expensive failures. You can automate schedules so systems only run when needed. And you can then also integrate them with other building systems such as security, fire and access control for even greater efficiency and resilience. Now, it's not necessarily easy to do this, and the building management system or energy management system itself won't save you energy. It's actually analysing the data and taking action on it that will. Paying attention and tuning the building over time can give large savings just from avoided waste and better maintenance. So now I want to look at the energy audit, which is your initial roadmap to savings. And this is where projects can go off the rail because they just go in and start something because a vendor recommended it. And in my experience, vendors typically exaggerate savings by, wait for it, a factor of pi. It's 3.14157. And, maybe that's a slight exaggeration, but in some cases it's very true. They really exaggerate the savings. So you go off the rails if you don't have a clear plan. And this is where an energy audit can really help. And you need a good quality energy audit. A real energy audit isn't just a quick clipboard check, walkthrough and tick box. It's a data-driven, systematic process that uncovers hidden waste and prioritizes solutions, both by the return on investment and the risk involved in implementing the solution. So an energy audit will start with data collection. Typically, it starts with at least 12 months of energy bills, preferably 24 months. The equipment specifications, asset register, building plans. The more granular the data, the better. Next, an on-site assessment is done that is very thorough. That inspects all systems, HVAC, lighting, process loads, plug loads, tools like thermal cameras, data loggers, temperature loggers, and power meters are used. Occupants and operators are interviewed. They can know where the problems are, even if they can't quantify them. Once you have the data, the energy auditor will analyse it, benchmark the building against similar facilities, and identify the biggest energy users and the worst offenders in respect of wastage. Then an energy auditor will start to identify different savings measures, look at the impact of each one, and calculating the impact, not just taking a rough guess. Projects that can then be prioritised by the payback, risk, and the impact on operations. An energy auditor will present the findings in a way that decision makers can understand and access on. Now, if you don't have energy auditing skills in-house, bring in a certified investment-grade energy auditor. And one of the differences between a good and bad audit will be the trust in the audit and the willingness to implement the advice. Good energy audits, where the energy auditor has a strong relationship of trust, is not exaggerating the savings and is not underestimating costs, will get projects funded and built. Bad audits, where straight away there's cynicism about the results or a lack of corporate commitment to move ahead, will just go like dust. So implementation is turning the results or the recommendations in an energy audit into results. An energy audit doesn't save energy, it just tells you what to do. And this is where many organizations actually stumble. They get a list of savings recommendations, but nothing happens. And some of the reasons would include, as I mentioned, the lack of trust in the energy auditor. Maybe it looks too good to be true, and sometimes it is. But there's other very important issues. It can be lack of ownership, unclear priorities, fear of disruption, and don't let that be you. And right at the start of this video, I talked about one of the issues that people aren't sufficiently committed enough to implement energy savings activities. I'm not going to pretend that it's easy, but with commitment, you can get genuine savings. So one of the ways you can do this is start by quick wins. And often an energy audit will have a list of measures that have a payback of 1 year or less. They will often include things like optimizing schedules, HVAC control fixes, and other items. Lighting upgrades normally the payback will be longer than a year, but they can still have quite a good payback, and particularly considering the lifetime of the lights, often provide an excellent return on investment. So these projects, when implemented and the savings can be demonstrated, can help build up momentum. And then if you're careful about locking away the savings into, say, a revolving fund or some other fund for further implementation, they can free up budget for bigger projects. And for larger retrofits like chiller replacements or upgrades to the building envelope, you can develop a clear project plan based on the audit. You can assign responsibilities, set deadlines, track your progress. You can use your energy management system or building management system to verify savings in real time and put in place a measurement and verification plan and do regular monitoring and reporting on your energy use. Now, if the numbers don't match the expected savings, find out why and fix it. Now, behavior change also matters. You can need to train staff for new systems. You can set up dashboards or feedback systems. so occupants or operators can see the impact of their actions. You can recognise and reward teams that hit energy targets. So this is a bit of a corny statement, but culture eats strategy for breakfast. If people don't buy in, your savings will evaporate. So view an energy audit as an important starting activity, but aim to get long-term ongoing improvement in energy performance. In order to get that, a business needs effective energy management as an ongoing priority. It needs to be important to the business. It needs to allocate the resources and time to get the savings, monitor the savings, and continually improve. So continuous monitoring, measurement, and verification helps lock in the gains. So energy efficiency isn't just a one and done kind of project you can do. Systems will drift, schedules will change, equipment can degrade. With that ongoing measurement and verification, or M&V, depending on the type of upgrades implemented, you could lose up to 50% of projected savings fairly quickly. Now, it really depends on the project. That's not always the case, but that is possible. So try to set up a regular review process. Use your building management system or your energy management system to track key metrics like energy use intensity, peak demand, equipment runtime. Compare actual performance to your baseline and projections. Investigate anomalies. For example, are systems running outside of scheduled hours? Are your set points being changed? Is equipment cycling more than it should? Fix the problems fast and document the results. Now, this isn't just about accountability, it's about continuous improvement. So now I want to look at emerging technologies and what's next in energy efficiency. So the world of energy efficiency is evolving fast. Here's what's coming down the pipe. So we have continual improvement in technologies such as lighting, always getting better. HVAC systems just gradually keep getting better, not at the pace that we've seen with lighting, but still getting better. Some of the newer ones are energy storage. Batteries are becoming more and more cost effective, and particularly where you have high demand charges, energy storage can help you shift loads, cut peaks, and even in some cases, if your tariffs are quite high, take advantage of lower cost power at different times of day, storing energy to use that time at later times of day. Now, in some markets, depending on the tariff structure, battery systems may be able to pay for themselves in under 5 years, often if they're paired with solar or demand response programs, rooftop solar. Now, thermal storage is also very interesting and can be a great tool to minimize peak demand. Electric vehicles and charging infrastructure. So EVs are coming, whether you're ready or not. And if you're looking at your buildings, installing charging stations isn't just a perk for employees or tenants. It's actually a strategic move that will add value to the building. Now, smart charging systems that take peak demand into account and at times when you use energy and when energy is being produced if you've got rooftop solar, smart charging systems can optimize when and how vehicles are charged, reducing peak demand and maybe even providing grid services in some cases. Start to plan for this now before your parking lot is full of EVs and your electrical infrastructure is maxed out, and watch out for vehicle to grid. It's still on its way, but it's coming, and that will really open up the potential to use vehicle batteries to help power buildings. Now, smart grids and IoT integration are another area. So smart grids are changing the way energy is distributed and managed, and with real-time data and advanced analytics, utilities and building owners can optimize supply and demand, reduce losses, and respond to grid events automatically. In some places, you can go on a spot price, and if you effectively manage that, just saying that's a high-risk strategy, but if you're comfortable about managing those risks and you've got strategies in place to manage those risks, you can actually get large savings on your energy bill. So devices, smart meters, sensors, actuators can provide granular visibility and control over every aspect of building performance. Now, the results are great, but you have to view the sensor not as the solution, but as analysing and acting on the information provided. If you analyse and act on the information provided by these sensors, you will lower costs and you'll get higher reliability and more resilient operation. Now let's look at AI. It's the buzzword. What can you do with that? Well, data is everywhere, and we're getting, in some respects, in some buildings now overloaded with data, but insight is harder to achieve. So advanced analytics and AI are starting to increasingly turn raw data into actionable intelligence. Now, I actually think the term AI is perhaps a bit overused, but some of these advanced analytics, which may include machine learning algorithms into them, can help save energy. Predictive maintenance algorithms can help spot equipment failures before they happen. Machine learning modules can help optimize schedules, set points, and control strategies, including demand management in real time. And the best part is that some of these tools learn from their experience and get smarter over time, delivering compounding returns. So what does success look like? Let's just look at a recent project, a retrofit of a 20,000 square metre or 200,000 square foot manufacturing plant. The team started with a comprehensive energy audit. They found that the building envelope, it was a high-tech manufacturing plant where HVAC was important for air filtration and maintaining stable humidity and temperature. So they found that the building envelope was leaking like a sieve, and the lighting was a mix of fluorescents and metal halides. Here's what they did. They sealed the envelope and added insulation and cut heating and cooling loads by 18%. Upgraded to more higher efficiency rooftop units with demand control ventilation, saving another 22%. Swapped out all lighting for LED with occupancy sensors, slashing lighting usage by 60%. And they installed an energy management system to monitor and optimize everything in real time. The result was a 28% reduction in total energy usage, verified with measurement of verification. And the payback was under 3 years, and the improvements in comfort and productivity were immediate. So that's an example of what can be achieved. So why do projects fail and how can you fix them? Let's look at the barriers. And most energy efficiency projects fail not necessarily because of the technology, they fail because of people and processes. So here's some of the barriers and how to overcome them. So one of them is a lack of data. If you don't have good data, you can't make good decisions, and energy auditors can make big assumptions that are wrong. So you need to invest in metering and monitoring. There can be a split incentive. If the people who pay the bills, like the tenants, aren't the ones making the decisions about the equipment, nothing will get done. You need to align incentives so that maybe savings are shared with the tenant and the owner. Set clear targets, make energy performance part of everyone's job. There can be fear of disruption. Yes, retrofits can be messy, but with proper planning and communication, downtime can be minimised. Schedule work during out of hours, stakeholders before. But the number one, and here it comes, I think, is short-term thinking and not viewing energy efficiency and energy management as something that is continuous. So don't just face the fastest payback. Look at life cycle cost, risk, and resilience, and be prepared to invest for the longer term. Now, sometimes the best investments will take a little longer to pay off, but they can deliver much greater value over time. You need to view effective energy management as an ongoing activity. So what role does certification and training play in achieving these results? So if you want your projects to get funded and built, credibility matters. And that's where certifications like the Investment Grade Energy Auditor, IGEA certification come in. These programs aren't just about theory, they're about energy auditors having real-world skills that can really help their clients reduce energy usage. So if you're on IGA, you'll learn about how to conduct rigorous energy audits, accurately predict savings, and present findings in a way that gets buy-in from decision makers. So if you're serious about energy efficiency, invest in your own skills and those of your team. The difference between a report that gets implemented and one that collects dust, well, it's largely about trust and credibility, but as I said earlier, it's also about having that organizational commitment and buy-in to view this as a serious activity that they're going to invest in the long term. And this then leads to building a culture of continuous improvement. Energy efficiency just isn't a one-time project. It's the mindset. The best organizations treat it as a core value, not just as a side project that you do just because there's some incentive available. They'll set clear goals, track progress, and build up a culture by celebrating wins. They invest in training, share best practices, encourage innovation. They don't settle for good enough. They're always looking for the next opportunity to improve. Now, if you want to stay ahead, build a culture where everyone from the top of the organization down to the maintenance crew owns energy performance. So the bottom line, why does this matter? Well, energy costs aren't going down. Carbon regulations are only getting tighter. Customers, investors, and regulators are demanding more transparency and accountability. And if you're not taking energy efficiency seriously, you're not just missing out on savings, you're putting your organization at wider risk. If you get it right, the rewards are huge. Lower costs, higher asset value, improved comfort and productivity, and a reputation as a leader in sustainability. So to take the next step, if you're ready to stop wasting money and start seeing real results, don't wait. Start with a real good quality investment grade energy audit. Fix the basics. Invest in the right technology. Train your team. Deploy an energy management system like ISO 50001. And if you want to take your skills to the next level, check out the Investment Grade Energy Audit Certification available on the Sustainability Education Academy. First lessons are free. I'll show you exactly what separates a report that gets built from one that gets ignored. You may also be interested in our 6-course certification series on energy efficient building envelope design, on our ISO 50001 energy management system course, and also on our standalone course on commissioning, managing and reviewing an energy audit, which is where you want to contract in an energy auditor and you want to get the best results from that energy audit. So in conclusion, make energy efficiency your competitive advantage. Energy efficiency is the fastest, most cost-effective way to reduce costs, cut carbon, and future-proof your building. The fundamentals matter, and I've touched on 4 of them: envelope, HVAC, heating, ventilation, air conditioning, lighting, and controls. Never skip a real data-driven audit. Implement, monitor, and adjust. Stay ahead with emerging tech. And above all, build a culture that values energy efficiency, that is focused on energy management, and builds a culture of continual improvement. So if you also want more strategies for energy efficiency, please subscribe to this channel. And also I'd love it if you could put your energy efficiency challenges or questions into the comments. Thanks for watching and see you next time.